Let's graph the function e raised to the x. E actually is on your calculator. It's a number. It's another number like pi. You know how pi was found when we were working with circles, and it was an irrational number. It has numbers behind the decimal forever. So does e. To find the value of e in your calculator, you'll need to locate your ln button. ln is generally on the button, and then above the button is e to the x. And if you're using the calculator I suggested for this class, when you press your second ln button, it'll give you e and a little caret indicating it's an exponent, followed by a parenthesis. So if you just put in 1, it'll tell you that e is approximately 2.7182881828. But there is no real pattern to this number. It goes on forever and ever. So if we make our little xy table, so we have some points to graph, we're going to look up here at the exponent, and we see that x is totally alone, so we'll put 0 in as the center number. We'll go a little smaller and a little larger, and I'm going to be using my calculator to calculate all of these numbers. E raised to the negative 2 power is 1 over e squared. But I need a decimal for that so I can graph the point. And the calculator says it's 0.1353, and we're not going to be very accurate, so you don't need to carry out this decimal very far. Next we have e raised to the negative 1, which is the reciprocal, 1 over e, and the calculator gives me a number for that as 0.36787. Again, I don't need to be very accurate. E raised to the 0, well, every number raised to the 0 power, with the exception of 0, is 1. E raised to the 1 power is in fact e, and that decimal was given to you earlier. It's 2.7182, and then we need to find out what e squared is. And we get 7.389. So let's try and graph these points. Negative 2, positive 0.1, negative 1, positive 0.3, 0, 1, 1, 2.7, and 2, 7. Oh, well, we're off the graph again. So we can see that this is another increasing function, and it's increasing because the base is bigger than 1, and we have an asymptote here at the x-axis once again. Because here's your function, and the number that you can add to this that's not part of the exponent indicates where the asymptote is, and that's at 0. So our domain for this function, and remember this will be on the final exam, domain and range, is from minus infinity to positive infinity, from the left to right, and the range is how low it goes, doesn't quite get to 0, and how high it goes, off to infinity.